Hi everyone, today we're going to learn how to do JavaScript with WebGL in a web browser using Three.js. So let's get started. I've got some basic boilerplate here. Let's just go over it so that we understand what's going on. We're importing the library here from this URL. Okay, I'm going to grab the Windows width and height. Create a new scene and a new camera, passing in the width and height, and some other things that you can look up, not as important. Set the position of the camera a little bit up on the y-axis and a little bit back on the z-axis. Or sorry, forward or back. I think this is positive and that's negative. Establish a renderer, passing in this option here. And I don't need this fog yet. And then I'm just adding that renderer to the DOM, the renderer's DOM element rather, which is a canvas. What does that look like? Let's have a look. Here's that canvas that was created by Three.js and added to the DOM. DOM meaning the document object model. Look that up for fun reference. I'm just going to create a square. Plain geometry, give it the color purple. This syntax here is the same as doing this. Color colon color is the same as just color. I'm passing that into this basic material and creating a 3.mesh, which represents a 3D object in the scene, and adding it to the scene. I'm not actually using this method yet. If I get rid of this and just call renderer.render and prove to you that I'm doing something. It's the same thing. However, I like having this animate function that I call here, and then it calls itself again and again and again and again using this request animation frame API provided by the browser. Alright, so that's the basics of that. What I'd like to do is add a bunch more squares and have us fly through them. Kind of like we're traveling through some abstract landscape. So we've got one square. Let's orient that square so that it's sort of flat as if it were on the ground or above us. And to do that, I'm just going to rotate it. I'm going to say mesh.rotation. It's rotating from facing us to flat. So I believe that's along this axis, which is the x-axis. Equals 90 divided by math.pi. Actually, I think I got that backwards. 90 times math.pi? I'm trying to convert degrees, 90 degrees, to radians, which is what the rotation method wants. I don't know if that worked or not. Side equals 3.double side. I think that's the syntax. I'm not sure. I want to tell this material to be double-sided, because by default it's only one-sided. That is to say, every 3D object has a normal. That is a line that's perpendicular to its face. Let me use an example of my palm. So the line that's pointing up, that indicates that's the top. So the bottom would be invisible in under regular circumstances. Let's grab this one here, just for that. Here it is, 3 capital D double side. Okay, that. All right, there it is. And it looks like it's oriented properly. Did I get the, no, that's the wrong one. Let's grab this one. That rotation times math.pi divided by 180. Okay. So I've oriented, let's make it a little bit larger too. I'm going to say width is 2, height is 2. I can see it a little more clearly. And why don't we add a bunch of those? We could add a bunch like this to use a programming construct called a for loop. For let I equals 0. Start with the initial condition, and then a conditional saying repeat until this condition is met. Squares. And then a third thing is like an iterator. It's kind of a strange construct, but it's used a lot, or used to be used a lot. You can use an array method instead, or a while loop. I'm just going to stick with this for now. One thing I need to do is define num squares. And I'll say that's equal to 30. Save, and you don't see much difference here because every single square is sitting right on top of each other. If instead we set the position, mesh.position.set, I have a minute and a half left, and we'll give it some value for x and y and z. Let's say that z is -I, so they'll move back into space. And so is y. Y is -I as well. Now, we see them all here. -x as well. -I for x. Okay? Yeah, instead I'd like to have them kind of splayed out in front of us. I'm going to go ahead and define these x, y, and z. Const x is equal to math.random. Actually, math.floor, math.random. So math.random is going to return a value between 0 and 1, and I want that to be rounded around. Okay. Times 10. And then I want to offset that so that it's 5 in the negative axis and 5 in the positive axis. And if I pass that in for x, looks like that. Let's do the same for y. And same for z as well. Whoops, my buzzer's going off. Let's just keep going anyway. Cool. That's interesting. It's not awesome, but it's kind of interesting. And if I save it, it's going to regenerate them again and again. And now let's fly through them. We could move the camera in the scene, but I want these to kind of continuously fly at us. So if we just move the camera, we'll just move past them and they'll be gone. What I want to do instead is move them past the camera, and once they've gone past the camera, I'm going to move them back in the scene so that they fly at us again. There's a couple of ways to do that. My favorite way to do that is to refactor this for loop so that I'm just calling get square each time, and I'm going to define what get square is. It's a function which includes all of this code. It kind of it wraps the reusable part, the repeated part of the code. Yeah, and it also acts as kind of documentation too. Instead of adding a comment, I can just name the function, what it's doing, and with the idea that it would be more readable to me in the future or to someone else who comes in to read this code. I'm just going to add this update method and then we'll be done. The update method, let me change this. I want to just return the mesh and then say let square equal get, and then scene.add square, kind of like this. Now you shouldn't see any change, but now I'm calling this reusable chunk of code which returns this thing. I take that thing and I add it to the scene like that. I can also say squares dot push. So I'm using a JavaScript array to hold on to that thing I just created. Better define that array. Const squares equals. And in JavaScript, to create an empty array, you just use this syntax. You could also say new array. But I like this method better. It seems much more direct and clear to me. Should be squares. Okay. Still no change if I save it, but now I have a reference to every one of those squares. And I can, in my animate method, the method that's called as frequently as possible in the browser to update the scene, I can loop over these squares.forEach, and then for a for each method, you pass in a method. Well, hang on a second. Let me explain. For each one of the squares, I'm going to represent squares as s, do this thing. s.update. What I'm saying here is, hey, go through this array for each one of them. Take one of those things and then call its update method. If I save this, it's going to break. Because currently, this square doesn't have an update method. It's just a Three.js mesh. Instead, I'll return a JavaScript object with a property called mesh. This is the same as typing this. It's just a little bit briefer. It also has an update property. Oops. Update, like that. Which I haven't defined. Let's define it real quick. It's a function called update. And in it, I'm going to have nothing happening yet. No operation. And also I need to change one thing, because I'm trying to add this generic JavaScript object to the Three.js scene, and it doesn't like to do that. It's like, dude, I can't add that because it's not a Three.js object, but it has a property, mesh, which is a Three.js object, and that is happy to do that. And it's happy to run update now too. What is update doing? Right now it's doing nothing, but we could have it do something like, for example, rotate the mesh every frame, like that. So now we're animating using this update method that's called for each one of the squares, all 30 squares, as often as possible inside of this animation loop. It works out to about 30 or 60 frames a second. I'm not sure. Probably 60. And we can modify the rate of that, make them spin slower. Or what I really want to do is position.z and have them move toward the camera like that. Yeah. That's it for now. Next time we'll change the color of the squares, and we'll position them so that they are either above or below the camera, not all through the y-axis. Yeah, and then we'll have them reappear back in the scene as they fly back in the camera, so you get this effect that kind of like this, where they just continuously fly at the camera and then reappear in the distance. You can see the code for this here. I'm just saying, if you fly past the camera, because the camera is sitting at, where's the camera? It's sitting at 5 in the z-axis. If you fly past the camera, then reset your position to the negative limit, which is 81 in this case. And because I'm using this Three.js fog, it's completely faded out at 81 and it slowly fades in. I'm using a filter on here to give it kind of a glowy effect. I can remove that just by removing the compositor, and these will be just plain. And you can still see though in the far distance here, they're almost invisible and they slowly fade in to give you a really nice infinite effect. Thanks for watching. See you next time.